Hi, everyone, and thanks for tuning in to BEaTS Research Radio, a podcast and YouTube channel dedicated to bringing our community closer to science in the research and engineering fields. My name is Nicole Chu, and I'll be your host on today's episode discussing the latest research on carbon nanotubes and their applications. I'm so excited to introduce our very special guest, Dr. Aiping Yu, who is an associate professor of chemical engineering at the University of Waterloo, the director of Carbon Nanomaterials Laboratory, and a researcher in the Waterloo Institute for Technology. She is also one of the 6 nationwide recipients of the 2020 E.W.R Steacie Memorial Fellowships. Welcome, Dr. Yu, and we are so happy to have you here today. Thanks for joining.
Good afternoon, Nicole. Thank you for inviting me. It's my pleasure to be here. I have been in carbon nanotube and carbon nanomaterial research for pretty much 20 years. So I'm glad I can share some of my knowledge and then some of my expertise to the society.
Wonderful. Thank you for joining us today again, Dr. Yu. So I'd like to start off our conversation by asking the first question. For those who may not know of our topic today, can you start by introducing us to what a carbon nanotube is?
Sure. The carbon nanotube, as the name shows, it's just a tube. But this tube made of carbon, and the tube diameter, is around a few nanometer. But the length is varying from few nanometer to 100 nanometer or even few micrometer. Basically, it means you can control the length. The carbon nanotube, it's very small. So for sure, our eyes cannot see it. You have to use a special equipment such as the electronic microscope and see from the electronic microscope. And then in the microscope, what you see actually is like a wire. It's like a band of wire. The carbon nanotube in technology, actually we category to single wall carbon nanotube, which is like one atomic carbon layer. If I bend it and make a tube, this is one atomic layer. This is called single wall carbon nanotube. And then I could have a few atomic layer, or we call graphene sheet, and then you roll it, you bend it, you get a few walls, a few layer walls. This is called multi-wall carbon nanotubes. The property of a single wall carbon nanotube and multi-wall carbon nanotube, they have big difference. Because it's a tubing, it's like a tube. So it's only one dimension. The diameter dimension is in nanoscale. So we also call carbon nanotube is like one dimension nanomaterials. Or sometimes we just generally call it one dimension quantum wire. This is some academic names. The carbon nanotube was the first produced by a scientist called E.W.R in Japan. So it's pretty much 30 years since discovered or invented in 1991. Carbon nanotube research is pretty much the driving force for the earlier entire nanotechnology. So you heard about nanotechnology pretty much in around the 1990s, but the early time of nanotechnology is always connected with the research of carbon nanotube. People have discovered, oh, carbon nanotube has this amazing property, and later and then have another amazing property, and this property can drive the development of this electronic device, and also driving another device. So it's always connected, and then push the whole nanotechnology area moving forward.
Wow, that's so interesting.
General about the carbon nanotube.
Oh, well, thanks for sharing that. And you mentioned how this field is relatively new, just 30 years, and the properties of carbon nanotubes. What makes them different or better than other materials we're using right now?
Yeah, that's a very good question. As you mentioned, it's related with property. The first property different and also amazing is electronic property. So for example, single wall carbon nanotube, these materials could be metal. So some type, basically one type, it means this tube, the diameter and the triangle, how you roll this graphene sheet. If in some circumstance you get this type of single wall carbon nanotube, this nanotube actually is metallic. So it's like metal. Metal, it means electronic conductivity is as good as metal, even higher than some conventional metal like a copper or aluminum in the wire. And then if you have a chance to bend another way, maybe tilt a little bit, and this way you get a semi-conducting carbon nanotube. So semi-conducting single wall carbon nanotube, the property is better than the silicon. You know, silicon wafer, silicon is generally in all electronics because silicon is a material you make a transistor. Transistor, you use transistor to make CPU, right? All the electronics has CPU, and then CPU use transistor. Transistor use silicon. Single wall semiconducting single wall carbon nanotube, the property is better than silicon. So since people discovering this in the 1990s, there are lots of research going on how to make carbon nanotube transistor or even carbon nanotube computer. So the still concept, the research is still going on, but because the challenge is really big, we are moving closer. Maybe in the next 10 years or 20 years, I don't know when, we can get a small device, cell phone or whatever, the electronic device made by carbon nanotube. This actually means the device can be even smaller. The cell phone maybe it's like can make a pen or make like a necklace. It's very small but run much faster. That is the first amazing property only carbon nanotube possess. The second amazing property is mechanical strength. Mechanical strength, people say if a material is really strong, we use steel, right? Carbon steel or stainless steel, this pretty much strong, very strong materials. But mechanical property of carbon nanotube is reaching the same level. It's really same level as steel. But the weight, you know, steel is really strong, but it's very heavy. The carbon nanotube is strong, but the weight, its own weight, is only the quarter of steel. So that's amazing part of a carbon nanotube. You know, I tell you some story. 20 years ago, the NASA, the US NASA, they put forward the concept is called space elevator. So 20 years ago, the NASA, they are imagining in the future, we can travel to the moon, to the other space, or even to the Mars by space elevator. So space elevator, it means we can travel frequently, right? Very frequently to the moon, to the Mars. This is even better than Elon Musk's spacecraft because the life cycle of space elevator is longer than the spacecrafts. So when NASA put forward the space elevator concept, they're looking for some material. So this material need to make elevator have to be really strong for sure, right? Really strong. But meanwhile, because this elevator need to go to the moon, so it's really long. So really long, it means its weight, its own weight is also big. So the materials have to be really strong, but meanwhile, its own weight, this translates to density, very small. So at that time, even now, the best candidate is carbon nanotube. Because carbon nanotube, as I mentioned, the mechanical strength is same level as steel, but its weight, its density is only a quarter of the steel. So for the initial few years, they are doing modeling simulation to see if this is possible. And then they identify it is possible. Theoretically, it's possible. Use carbon nanotube to build a long space elevator up to the moon. But practically, it's very challenging because when you produce carbon nanotube, you thought about it, it's like it's all by the carbon, it's without any defect, right? It's all by carbon simultaneously by carbon and connected. But unfortunately, in the lab or industrial level, produce carbon nanotube, we always have defect. It means it have a tiny pore. If you use a microscope, you can see some carbon atom is losing, you know. So practically, it's pretty much very challenging to produce carbon nanotube without any defect. So the research right now is still going on. How can we produce long carbon nanotube fiber and then without much defect or even minimize the defect? By this way, we can reach the best natural mechanical strength of carbon nanotube. I think these two are two biggest one, which the other materials don't have this amazing property. The third one is related with surface area. Surface area, because the nanoscale, all the nanomaterials possess high surface area. High surface area, it means with the same mass or same weight, for example, 1 gram or 1 kilogram, how much surface you possess. So carbon nanotube is reported around 2,000 meter square per gram. So that's really high. So these three are most distinctive properties of carbon nanotube. For sure, there are some other materials. For my research, I really take advantage of these three conductivity, mechanical strength, and high surface area of single carbon nanotubes.
Wow, so the amazing three qualities, the mechanical strength, the electrical and thermal conductivity, and the high surface area. So what are the current applications of carbon nanotubes right now in society? And what does your
like I mentioned, yeah, so carbon nanotube have produced for pretty much 30 years. But the challenging is really big is, for example, we say the carbon nanotube, especially single carbon nanotube, has an amazing property. It could be metallic. It means some single carbon nanotube is like behave like metal, very high conductivity. Some like semiconductor, better than silicon. But practically, when you produce it, naturally single wall, multi wall, they turn to like entangled together. So nature give you a trial, but unfortunately, it's very difficult to separate them. This tube is single wall metallic. This is single wall, and then metal. But they are connected. They're kind of entangled. How can you separate them? So this is the biggest challenge in the whole nanotube research. There are some development for sure. People say, okay, maybe we can find a way to burn the metallic tube. Just leave the semiconducting tube. But unfortunately, when you burn the metallic, you can't make a natural because they are together. It always have damage on the semiconducting carbon nanotube. And some researchers say maybe we can produce pure, whatever you use, what type of catalyst, what type of technology, you can produce maybe 90% metallic. We always call enriched. Enriched, it means it still has some combination of both. 100% pure semiconducting tube it's pretty much right now is still impossible. I hope with the development, with the scientists' involvement, development in the maybe next 10 years, we can overcome this big challenge. So we can see the future. The electronics, if it can turn to, like I mentioned, the cell phone can turn to like a necklace. this should be the contribution from the carbon nanotube.
Yeah.
The other challenge, for example, mechanical strength is as good as steel, right? But I mentioned it always has a defect. This wall has many pores because when you produce the nanotube, naturally you have to use a catalyst. Catalyst is a tiny particle, it's metal. So after produce nanotube, you have to remove this particle. When you remove it, naturally you left lots of pores. So this pores we call defect. Defect reduce the mechanical strength of carbon nanotube, the reduction is quite significant, at least 50% reduction about the mechanical strength. So that's what the other big area scientists are working on, try to produce nanotube as long as we can without much or minimize the defect. So hopefully in the future we can make many like plastic and other material really strong, or even make the space elevator. The application, like I said, the research is still going on to overcoming the challenge. The good news is practically in the industry, which is you can see there are industries using carbon nanotube. As far as I know, there are 3 industries practically using carbon nanotube, and then it's also pushing them using more and more. You know, one area is energy storage. Energy storage for sure is connected with electric vehicle, right, or fuel cell vehicle, because all this environmental issue, and then electric vehicle will dominate the market in the future, and there are, for sure, Canada need to catch up with the whole world and then use more and more electric vehicle and fuel cell vehicle. Actually, you know, the Canada is the leading role in the whole world for the fuel cell development. So in the battery area, I know some industry using carbon nanotube as a conductive additive. Conductive additive, it means battery battery basically is anode, cathode, and then so you have electron go through. So cathode material is non-conducting. So the industry try to add some carbon nanotube to bind the we call bind with cathode to make the battery the cathode more conductive. By this way, electron is easy to transfer, and then increase the life cycle, make the battery last longer and then run faster. That's one benefit of using carbon nanotube. The other area is the fuel cell. Fuel cell vehicle is using hydrogen. Hydrogen from the water, right? It's really zero emission vehicle. This is, I think, in the next 20 years, I think you will see. I imagine in next 20 years, for sure, will be more and more fuel cell vehicle drive on the highway and then on the road. Fuel cell is a technology using hydrogen, but the hydrogen convert to electricity need a catalyst. Catalyst need support. So the Ballard is the biggest fuel cell company in the world, which is located in Vancouver, and they are starting using carbon nanotube as catalyst support, basically to lower the platinum, to convert the better convert the hydrogen to electricity and water. So this 2 area in storage, energy storage area, battery and fuel cell, they are using carbon nanotube. Another practical industry application is is the medical device. You know, some medical device, they require the device anti-static. Anti-static, normally lots of medical devices actually you are using plastic. Plastic is pretty much has no anti-static property. They can absorb dust, right? So the advantage of carbon nanotube is making the many plastic, especially medical plastic or polymer, anti-static. So it can get better absorption of some materials or resist absorption of some materials. Because the carbon nanotube, you can add minimum, very small amount to the polymer, make it anti-static. Compared with conventional materials using maybe carbon black, for example, you have to add 5%. With carbon nanotube, you only need 0.5%. It's 100 times lower ratio of carbon nanotube, and then can reach the same property as the conventional materials. So this is, in my mind, there are three areas using practically using carbon nanotube now. I'm sure in the future you can see, you will read more and more reports, more and more areas start using carbon nanotube, adopting carbon nanotube, because with the cost reduced, and then people start try to adopt it because the property is so amazing, and then you can use much less compared with other materials. For my own research, This is directly related to my own research. I'm working on battery and supercapacitor. I use carbon nanotube as additive to make a device more conductive and then possess or store more energy. I have also research using actually is using plastic. It's not for medical device. It's for pipeline. A pipeline, Canada pipeline, they actually is not using metal. It's using metal, carbon steel metal, but along the carbon steel metal inside, you have the cold, very thick we call polymer layer. Normally it's polyurethane. This layer have to really thick because Canada the oil sands have big heat or big punction to the pipeline, either to break pipeline. This insulation layer try to serve as a protection layer to avoid the sand hit the pipeline. But if this polymer layer is too thick, right? It's too thick, so the real area for oil transportation is real small. So you have to think about how can we reduce insulation layer from maybe 5 inch to 1 inch. By this way, you can have more oil transporting. And then to reduce the thickness of a layer, it means this layer have to possess same protection of 5 inch. How can you do that? This is what I'm working on. Use carbon nanotube plus another new materials also called graphene. They serve as a barrier to the polymer to increase the polymer abrasion property, but meanwhile block the salt and other corrosion agent go through to attack the pipeline. This is practically in my research area. I'm using carbon nanotube. I'm using graphene. Graphene is more like a mother material of carbon nanotube. Graphene is single layer graphite, and then when you roll it, it turns to carbon nanotube. So they are like a sister materials, or people even call mother or sister, mother and sister materials. So one is called carbon nanotube, one is called graphene. These two carbon nanotubes are my two building block in my research. Both are carbon materials.
Wow, that's so interesting to hear. And thank you for sharing that. Yeah, we're definitely looking forward to more of your research coming out in the future and learning more about the applications of carbon nanotubes, and hopefully one day to see that phone become a necklace, truly. It's so spectacular. Yeah, well,
thank you.
Yeah, thank you for taking the time to join us today, Dr. Yu. Your research was so interesting to hear about, and I'm sure everyone listening felt the same. So thank you once again.
It's my pleasure. It's my pleasure, but I'm sorry, I probably used too much time.
Oh, no worries about that. It was definitely very interesting to hear in detail of all the carbon nanotubes. So thank you everyone for joining us again. This podcast was brought to you by the University of Ottawa Heart Institute, BEaTS Research Lab, and the Department of Biochemistry, Microbiology, and Immunology at the University of Ottawa. Also, a big thank you to our director, Dr. Emilio Alarcon, and the whole BEaTS Research Radio team, and see you all next week. Thank you.